Okay, so this is the training guide that I'm working through. Again, it's just our standard Introduction to OpenBridge Designer training guide, and I'm going to take a look at these first few reports that are available here in OpenBridge Modeler for this session. I'm going to move this over to the side and start working through each of these. Again, feel free to throw any questions into the chat window as we go. So this file is in the Module 8 folder, and this is just the completed bridge from Module 3, just a simple little two-span precast girder bridge. And I'm on the Analysis and Reporting tab, so the first report we'll take a look at here is the Quantities Report. Now, by default, when you open this up, it opens up our preview window, and this is the same report viewer that we use in Leap Steel. Leap Bridge uses it a little bit as well, and it's the only one that we use here in OpenBridge Modeler. So you'll notice over here by default we have a couple of options that you can select, either the active bridge or all bridges that you want to report on, and same with bridge units. A bridge can be made up of multiple units. By default, there's always an active bridge and an active unit, and that's what this report defaults to. I only have one of each in my file, so I'm just going to select Submit, and off it goes, and it creates this report. Now, we'll notice in the report here, there's several sections to it, so we do group things by superstructure, then substructure, and then we have some miscellaneous quantities here at the bottom. Now, within the report, you'll notice, for example, under superstructure here, it calls out the component, what type of a component is it, what information do we know about it, any material that's been assigned to that component, and we'll get back to materials here in just a moment, material type, the pay unit, which is derived from the material type here, the units or unit price, that's also tied directly back to material. And then the quantity is in the next to last column. And then assuming you have a unit price assigned, we'll also come up with a cost estimate as well for each item. So, we've talked about materials here. We'll notice pretty much everything here, I believe, has a material assigned to it. And so it has a unit price and a pay unit as well. So let's take a look at that material information first before we get too much further. So as you go through the modeling process, and this was added quite a few versions ago, whether you're placing a deck or you're placing beams or piers or abutments or anything else, material is an optional thing that you can select as you place those elements. So as you go through the process of creating the model, using these individual tools up here, you can assign materials to every single thing as you go. You can always go back and change them later on, but you can assign them as you go. And then more recently, within the Bridge Wizard, so about 1 to 2 releases ago, they added a materials tab there as well. So when you model the bridge with the wizard, if you want to assign materials, please go to this tab, select materials for everything that applies to your structure. And then when you select OK, those materials will get assigned at that time. Otherwise, it was almost like it wasn't saving as much time as you'd hope, because you had to go back without that materials tab on there and assign materials to everything as you go. So where are these materials at? So again, for any element out here, you can go click on it, go to the properties window, and you can see the material that's assigned there. If you click in the window, then you could go select some other material if you need to change it. So where are the materials? Okay, back on the Utilities tab, one of the libraries up here at the top is material. And each agency typically has these set up based on the materials that they use on their projects. What we're looking at here is one of the default template library that more or less comes with the software plus a few other items down below. But you'll notice there's a concrete tab, there's a steel tab, and a miscellaneous tab. So this is really twofold here. The ability to define all the analytical properties for the material out here to the side, including unit weight. But there's also, as you notice, a unit price column that's really only used when that report is generated. So the unit price isn't placed on the element. The only thing really placed on the individual elements in the drawing is the material name itself, and then it pulls this information from the library at the time that we generate the report for the unit price at that time. So again, we have everything concrete related is in this tab. All of our steel here, so things like pile, your rolled sections or plate girders, all of those can be defined here. And then miscellaneous things like our field splice bolts and our excavation quantities, bearings, bearing pads, traffic barriers, and so forth are all here. So customizable library, very easy to go in and modify things here, or you can copy and paste from here to Excel, make the changes in Excel, copy and paste them back. So back to our reporting tab. Let's reopen that report and regenerate it. Well, it's open. We'll hit submit. So most of the quantities that we see here, we're pulling directly from the elements. So things like deck and beam and on the substructure components, you'll notice we break these down into individual caps, columns, footings, piles, bearing seats. So we break all of those down. Even the wing walls are listed here. And then under miscellaneous components, again, those things like bearings and barriers and maybe excavation if it's present, those sorts of things. Haunch, I do want to talk just a moment about this haunch quantity right here. Usually not a huge player, in the overall scheme of things, right? But I do want to explain how we arrive at this number. And that really goes back to how you define the haunch initially. And this is especially true on a precast girder bridge. You have two ways of defining the haunch for a precast girder bridge. So let's get out of here just a moment. Let's go back to element selection here. Let's rotate this view around just a bit. Yeah, well, we can live with it where it's at. So I'll select one of the beams, tell it I'll go to properties, tell it I want to edit the beams. And let's take a look at how the haunch is defined on this particular beam here. So right now, the haunch is set to a 1-inch minimum clearance and a 3-inch camber. So we're using some use cases and equations that were developed by a Florida DOT. And based on these two values right here, we compute a starting haunch and an ending haunch for each girder. So we're allowing the haunch to vary along the length of the beam. So so what we do is we take the top flange width on each beam, and using these values right here, we can compute a haunch quantity for every individual beam. And so it's a very detailed, very precise number that you would get if you do something like this. The other option here, if you tick off compute, then you can give us just a vanilla starting value here. So you might put in 2 inches or 1 inch or 2.5, who knows, for the start and end value. And then if you do that, then the quantity that it would compute is just the flange width times the length of the beam times the average of these two guys here. So we're just going to have a more general number there versus something like this that might be a little more precise value there. But again, it's a relatively small quantity in the overall scheme of things. But just know that haunch is not something we're pulling directly from the model as you see it here. So if you're trying to click on elements and compare the solids area that maybe MicroStation is giving you, or that OpenBridge modeler, let's say, is giving you via MicroStation versus what we compute here, then haunch probably isn't going to match up. But otherwise, the rest of these should match up spot on. So Now, as far as the viewer goes, I think most of the stuff's pretty obvious across the top here. You can change this portrait or landscape. You can change the size of the paper, change the color of the page. There is a nice little watermark tool if you want to put on here that these are preliminary or 60% quantities or whatever. You can do that. What I really like are these tools over here right before the close window. You can export this out as a PDF. You can export it out as a web page, as a spreadsheet, a CSV file, text file, even an image. So for example, if I kick this out as a spreadsheet, so yeah, go ahead and create this for me, click OK, ask me for the file name, and I'll just take the default here, go ahead and save it, and then it'll ask if I want to open the file. I'll go ahead and say yes, and that will go ahead and open this up. So it's going to look identical in here to what it does in the report viewer. But the beauty here is you could go in and reformat this or pull this information and use it in your own tabular form. A couple of other numbers to note here. We do compute a bridge deck area. So what this deck area represents right here in this cost per square foot, but more importantly, the deck area, and it's shown here as well. That's the area, total top area of the deck, minus whatever area the barriers are taken up. So again, it's something you could compute by hand and compare with our quantities, but that's how you will match it. So it's not the total top of the deck, it's the deck minus the barrier area here. So keep those computations in mind there. All right, so that's our quantities report. Next up here is the input report. This one's pretty straightforward. Now, I'm just going to go ahead and kick off submit and let it run. But what I will tell you is that for the input report, this is going to help you when it comes to trying to QA/QC the model. All right. This report has been in the software almost since the beginning. We had one of our first organizations that started using the software came to us and said, hey, how are we going to QA/QC this model? Here's what we do today. We'd like to be able to have some similar functionality or capability. So we added this report to the software, and what that will do is it gives back to you all the information that was used to create the model. So for example, here at the very top, what type of bridge was modeled with this. So this is kind of like the add bridge window right here. But if you're familiar with OpenBridge and all the tools that are back here on the home tab that you walk through as you go through the process of modeling the bridge, and you're familiar with those dialogues, all this information here is going to make sense to you, because we're more or less just showing back to you what was in the windows when it was modeled, or maybe if modifications were made, those would be accounted for here as well. So for example, so one of the first things that's done is you go out there and you place the deck. So it comes in and it tells you, all right, the deck goes from this support line to this support line. Here's the deck template that was used. Here's the offsets as they currently are shown. What was the material that was used? And then what variables were overridden. So what are the default values of all the variables? And then here's a list of all the stations and values that were changed or overridden for every variable. And it just continues on down through here. Now down in the lower left of this window is what we call a document map, or it's what this report viewer calls it. But this simply allows you to jump to a specific area of the report and see that information. So it's just some links over here, if you will, that will jump to specific objects on the structure, whether it's the deck, the beams, the supports, the support lines, bearing information, abutment, wing wall information. So again, so like for beam layout here, all right, the beam layout was done. It went from this support line to this support line along this alignment. We use simple in lieu of continuous beam support. There were 5 girders. No advanced bearing definition was needed or used. And then here's how the beams were laid out, starting in spacing, starting in support line offsets. Were the ends of the beams skewed, yes or no? How was the spacing reference set, beam reference? Were these corded or not corded, so on and so forth. Let's see, let's jump down to support line. So here's the 3 support lines on this structure. There are 3 primary attributes here, being station, length, and skew angle. We also call out an azimuth direction there as well. And then if we go on down to the supports, so for each of the supports here, so here's the middle pier, materials used, what kind of an abutment is it, or this is actually one of the abutments, sorry. It was a pile cap abutment, and then all the dimensions on that, and then the pile location and information about those piles. So very detailed report, giving back to you, again, all the information that was used as input to generate the model. And again, same tools across the top. Can export it out to any of the formats we mentioned a moment ago. Also email it to someone directly from here as any of those formats as well. So back to analysis and reporting here. Next report up is the deck elevation report. So I'm going to select that. So this report's a little bit different in that you can, it prompts you for a start and end support line for generating the report. So assuming you want to do it for the entire length of the bridge, you'll pick the first one, select the last one and accept it. And then we'll go ahead and open up the deck elevation report. A lot of options here, all right? Before we actually generate the report, since every agency does these things a little differently, we try to support just about every option out there that you might need to generate these deck elevations. So even though it asked you on the way in for these support lines, you can change them here. So they're all listed here. So you could do something different. You can also offset from the support lines, because keep in mind, especially for abutments. Now for your piers, you probably don't need to do that. Well, yeah, you might. Let me take that back. But for example, for this support line right here, this guy right here is at the front face of the back wall, is where it's located. Now, some agencies might start, and since the deck runs all the way up to that support line, maybe you want to start it right at that support line, so your offset would be 0. But I have seen agencies, especially when they do deck elevation reports along the girder lines, they might start that at the bearing line, this blue line right here in my case. And that's about 1 foot off of the support line here. So if I wanted to mimic something like that, then I would put that offset into here and tell it, okay, move ahead 1 foot and use that value there. And that way you could start precisely on the bearing line here and end on this bearing line over here. Now, if you have multiple spans, you might need to generate that report for individual spans if you're going bearing line to bearing line. So keep that in mind. But that's where these offsets would potentially come in here. So these are longitudinal offsets relative to your support line. And then for transverse lines, and we'll try a few different options here. So we'll leave it parallel to support at the start here. So if you wanted 10th points, we would go in and set this to 11 points per span, but you could give us a straight spacing value here as well and do every 5 foot or 10 foot or some nominal value. We could do individual paths. We'll leave that off for just a moment and we'll come back and turn that on. And then for report type, we can do station offset elevation, XYZ, or a consolidated report that would be elevations, basically just a big table of elevations for every reference that you utilize to generate those elevations. We have some common references listed down here below, so if you needed elevations along the alignment, you just tick this one on. Same with left and right edge of deck. And then relative to the barriers that are in the model, you can pick the left or right edge of any barrier. And then we can also do along the center lines of the girders here. Now, one other key thing to note here, let's say 12 foot left and right of the center line of the bridge. You also wanted elevations there, and you don't have a beam there. That's fine. All right, we can include this. And then over here in the offset field, you can supply transverse offsets from any of these references here. So if you knew 12 foot left and right plus at the center line, you wanted to force it to compute elevations, you could put in -12, 0, +12, and it would give you all those as well. I'm going to do just beam paths here initially, select generate, and it will open up our reporting window and show me, again, for each beam here, what's my station, what's my offset, what's my elevation. Now you may notice here in the background, some orange dots appear on the model, and let's just minimize this guy out of the way. So there's those. So this is showing you everywhere it is computing an elevation for us. So again, this was along each of the girders here, so we can see where those 10th points were precisely located within the model here. Pull this back up. So again, station offset elevation. Over here on the document map, we could jump to any beam at any span and see the values as such. So this is for my second beam, starting here in span 1, again, stations, offsets, and elevations. Let's go ahead and close that out. Now you'll notice it did draw some blue lines here as well. Now again, we started this out parallel to support, so that's how these were computed, was parallel to the first support line. We could also give it an option here of normal to alignment. So if I hit generate here, then you'll see those support line or these blue lines rotate some. So now we may or may not get points, or we may not get 10 even spaces for all of the beams, right? Because this is skewed just slightly, even though it's only an 8-degree skew. We are missing, it's starting at the alignment at the support line. So where those two intersect, then it's going at the 10th points from there up to the next support line, and then dividing that by 10 and then going radial from there. So just keep those in mind when you do this, and that'll help understand the values you're getting back from this tool. A couple of other things we can do is we can do individual paths, and you'll notice that'll gray out the transversal lines here. And then that way, if this is skewed and you want elevations along just the 10th points of each individual girder, especially if they're flared, then this might be a better option for you. So if I select generate there, those blue lines are going to go away. We still have the orange dots out there, and now we get a different set potentially of stations and offsets and elevations. So just kind of keep that in mind, and that visual feedback is going to help you a lot to understand precisely where those things are going. Now over to report types. Again, we have station, offset, elevation, XYZ, basically the same kind of information, but coordinates. So if you wanted to generate maybe a terrain model of your deck here for contour purposes or some other purposes, you could pop this out to a text file or a spreadsheet or something and pull all these XYZ points out and create a terrain model pretty quick. Lastly, and this is probably the most common one I see in the in plans today, or look something similar to this, is this consolidated report, wherein it will go in and give you these 10th points in a table similar to this. So for my leftmost girder, here's my 10th points. And now with this set to individual paths, we do not get starting support line or bearing line values here. But if we turned off individual paths, and let's say we went back to parallel to support, then it would give us start support and bearing line elevations, as well as end bearing and support line elevations. So very rapidly give us all that per span. Again, now this may not be exactly like what you want to see in your plans, but you can, again, export this out to spreadsheet or CSV or text file, and using pivot tables or whatever, reformat this pretty easily and get this into a model, drawing model if you need to. Now, one other unique thing about this report is you can give it a name. So for example, if I come up here and I'll call this my webinar report. So down here at the bottom, you'll notice there's a button that says Save and Close. We'll tick that off. If you go back to Explorer, if you ever need to rerun that report for whatever reason, go back to Explorer and just start expanding within the OpenBridge model category here. You start expanding the last one. All the way at the bottom here is Reports. And there's the one that I just saved off, a deck elevation report. So if I want to open that up, what you need to do, you can't double click on it and have it do anything, but if you right click on it, click open, that will go ahead and open this window with all the options as you last had them set here, so that you can probably just hit generate and recreate the report very quickly. All right, next report up here is our beam report. So let me go ahead and open that up. So this automatically runs when we open it. It knows where the beams are, and it just does it for the entire bridge here. We only have one bridge and one unit, so it automatically does it. In this report, it's broken into 4 different sections. First one here is just the general beam report, where it gives you true length versus projected length. So if your structure was, let's say, on a significant grade, sorry about that. If your structure was on a significant grade, these two values might be different. The projected length being the horizontal length versus the length along the grade here. Bearing to bearing distances are called out here as well, along with the beam grade, the direction it's facing. Think kind of an angle, kind of a microstation angle, really, at this point, and then a rotation of the girders. And the rotation of 0 means they're true vertical, but there is an option when you place girders, and this is probably more common with box beams or U-beams or some of those, or deck bulb tees or something like that, where they might be parallel to the bottom of the deck. The top flange is parallel to the top of the deck, so we can give you the rotation angle there if you use that option. Next up here is beam elevations. Again, by default, it's going to do the 10th points, but you'll notice if you need some other spacing value or number of points per beam, you could change that here. And we'll give you both top and bottom beam elevations on this report per span. Next up is the haunch thickness here. So again, this really depends on how you define the beams when they were modeled. So if you use the compute option here, you should get some very precise values here for haunch thickness. And we do break this down by the left edge of the top flange, the center line of the girder, and the right flange, right edge of flange for all beams and in all spans. And so you'll notice, just to kind of point this out, again, when these beams were defined, we used a 1-inch minimum haunch, or 1-inch minimum thickness, and a 3-inch camber. And so for the beams on the left side of the deck template here, right here at midspan, there's that 1-inch value for the left edge of flange, because that was the controlling location. At the center line here, since this particular beam rests right under the the crown point, or the profile grade line, both flanges are right at that 1-inch haunch value here. and then the right flange happens to come into and be the controlling point, as we would expect at midspan for the two beams on the right edge or on the right side of the deck. And then lastly, we have haunch elevations here. So we have elevations on the top of haunch on the left and right flange of each girder here as well. All right, next up, bearing seat report. So we'll go ahead and kick that off. So I have for the bearing seats here, elevations at the center line of each of the beams here, at each of the supports, and the thickness at the center for each of those bearing seats and grout pads and bevel plates here. And if we scroll on down, it would give you the depth at the corner for each of these. Now this designation here, D1, W1, D1, W2, and so forth, is included in the report at the very bottom. So we insert an image here that we've created to help you understand what is D1, D1, D2, W1, W2, how do those all come into play. So D1, W1, D2, W1, so on and so forth. Again, so the depth is measured longitudinally, and the W values are transverse to your structure. So again, very precise values that we're computing here on your structure. Now, Camber. This Camber report, even though we don't draw the beams cambered yet, there is still talk of doing that. But even without them being drawn cambered, we can still precisely compute and give you reports on this information. So it'd be a matter of supplying back to us what is the camber value, what is the self-deflection, what are any additional deflection volumes here or values here. So you can fill this out yourself. Just populate these values here, and we will generate the report for you. And maybe you've computed these by hand, so it wouldn't take that long to input these. But for precast girders, we can read these values from LEAP concrete as well. So these values can be pulled from LEAP concrete. Now, I haven't actually run this particular bridge, analyzed it in LEAP concrete, and the way I know that is I tick this on, I don't see anything happen here. So to be able to use this toggle right here, you would have needed to have I need to close out of this for a second. You would have to go to the Utilities tab here, send your bridge to LEAP concrete, do all your analysis and design of the girders there in LEAP, and then send back to OBM and have it update the model for you with that camber information. And having done all that, then this would work right here. You could come into the Camber report here, and you could pull that information in, and it would pull in the camber and self-deflection values directly from LEAP concrete. So anyway, without that, you can come in here again and put in some value here for camber and self-deflection, and then generate the report for just that one beam in this case. For anything that's zeroed out, it doesn't compute anything. So it's going to be just for that one beam and that one span right now. But just to show you what it would give you in the report, we'll give you should be the final deck elevations for the structure. Again, should match what we saw there in the deck report that we generated earlier. And then you'll have your screed elevations that we compute based on those camber values, the girder top elevation at erection, and then the screed height above the girder. And again, that can be done for all beams and all spans once you populate the camber values. Lastly is the peer report, and this will go in and compute on not just piers, but basically it's all of the supports. Basic information about them, basically stations, elevations, and links for all the components. So, for example, here, so this is really, it says abutment name Pier 2. It comes in and says, okay, here's the elevation on the left and right edge of right into the cap. Here's the length of the cap. Here's all the pile. Here's their what should be their top and bottom elevations based on the model, the length, and also coordinates here. And then for the pier, again, same type of information, our cap left and right elevations and length. But then since this has columns, it's a 3-column pier, it goes in and gives us top and bottom column elevations and lengths, and then all the pile information underneath that particular pier. Again, just pulling the information straight from the model. So all this stuff should be a very simple overall byproduct of the model. Okay, so with that, I'm probably going to stop there and take a look at some of the questions. I know Alex has been, I think, answering some of these over here. Let's see.
Yep, the last two we haven't answered yet.
Okay, okay. Well, I'll go ahead. I don't know if everybody can see these or how that works. I assume they can. But for the material libraries, can you export the material library to XML or XLM? I assume you meant XML there, maybe. The material file here is an XML file to start with. And it even shows you the full path and name up here at the very top. So yeah, this guy is an XML file, and so if you feel comfortable editing in XML, then have at it. I'm a little more comfortable in Excel myself, but you can open it directly with an XML editor and absolutely make changes to it if you prefer to do it there. Otherwise, like I said, if you want to send this to Excel, you can select one or more rows from this table, right-click in the first column out here and pick Copy, and then open up Excel, paste it in there. So what I've done for agencies when I've assisted them with setting up their material library as part of their overall workspace is I just create an Excel spreadsheet just like this, copy and paste these values into 3 different tabs within a spreadsheet, let them, and usually they'll pretty much get rid of all of our information. The main thing they need to know is what each of these columns represent. Go in and put their information in there. And then they send me the Excel spreadsheet back, and I copy and paste the stuff from the spreadsheet back into here. So very very simple to update and modify. Is the offset along the baseline or perpendicular to the support line? So I assume that's for the elevation report, deck elevations here. So it really depends on which offset, because we really do both. Right, and just to clarify, and I assume I may have answered this earlier, but so these offsets here are longitudinal offsets relative to the support line. These offsets over here are transverse offsets. So relative to, let's say, the center line of the beam or the alignment or something else, then you could put offset values in here. If I remember correctly, you separate those by commas. So if commas don't work, try semicolons or spaces or something, but I think commas are the preferred method there. Does the Haunch quantity take into account vertical curves? Yes, if when you define your girders, you use the compute option there for the Haunch. So if I open this back up, let me go to beam definition. So as long as you do the compute option here and you give us the minimum camber and the desired camber at midspan, or maybe it's final camber at midspan, then absolutely, yes, we're taking into account where precisely is the bottom of the deck located based on the both longitudinal grade, so whether it's in a vertical curve or not, and the cross slope, and coming up with a precise quantity for the haunch. If you only give us a number here for haunch start and end, and you say 2 inches, let's say, then again, the value we're giving you for that quantity is flange width, top flange width, times this depth times the length of the beam. So we're just kind of giving you more of a nominal value there versus a little more intelligent value that you would get from the compute option there. Let's see, what were some of the other questions here? Is there a way to include imported geometry or custom parametric cells in the quantity reports? Today, I don't remember if we're doing the parametric cells. I think if you have a parametric cell, I believe, then yes, those can be included. If okay, big if here, right? On your parametric cell, if the assign tag process was done, so in the cell library, when you're sitting there looking at that parametric cell, each individual solid that's in there, or blob, if you want to think of it that way, you have to tell the software, this is a cap, this is a wing wall, this is a footing, this is a pile, and so forth. So you have to tell us what those individual things represent. But if you do that with the assign tag tool, and then you place a parametric cell in the model, then yes, we will compute the quantities on those for you. Is there a way we can assign a custom element ID for quantity reports? I'm not quite sure what you mean by that. I don't know if Alex is that.
No, the only, custom will be a microstation ID. It does it automatically because when you place a cell, there's a microstation ID element, but to assign it per se, it will be, no. I mean, I would say the parametric cell will have that. And as Steve was saying, if you tag it, it will be, oh, this is the footing, this is the pile, and then compute the quantity for that.
Yeah.
You want a custom element ID, the only thing that occurs to me is item types. Then you can assign whatever name to it,
right,
and report on quantities on that. So that actually on the next release, we are adding some customization of adding extra properties to any bridge element.
Yep.
So maybe that would be the item types there. Then you can really massage your quantities there.
Yeah, that's what I asked actually. When I messaged, go ahead.
Yep. So that would be the item types, because in item types, you will have access to the actual microstation properties of the solids. And then you will do even math operations if you want inside that.
Yeah, and why I asked the question is like when we create a quantity report over there, so we will be assigned with an ID for a particular element, but in the model will be assigned as a pier or a end bent or an abutment, whatever it is. So for that, if we can assign an ID, if the concrete grade is different, I think we can separate everything together when you're doing the quantity. That's the reason I asked that custom element ID. If we can do that, I think we can separate all those quantities together and extract the whole lump sum for concrete quantity for all the bridges together in the quantity estimation.
Could be. Okay. As I said, I mean, we're going to add these properties. One way that you mentioned this, for example, is that DOTs wanted to use these extra properties that you want to add to the elements. We call it item types to do, for example, pay items on budgets, right? So maybe that could be the way to do that. So you can be very creative on this too.
Yep. So that should be coming anytime. Yep.
Yeah. Thank you.
Next one here, for the longitudinal offset, I assume we're back to deck elevations here. Is that measured along the baseline or perpendicular to the support line? That probably depends on how you have these transverse lines set. If you say normal to alignment, then that's probably going to be measured along the baseline. Parallel to support, then I think it's going to be relative to the support line here. How does it handle straight girders on a curved alignment? Really well. For lack of knowing quite what you mean there, I mean, you can absolutely lay out straight beams on a curved bridge.
Yep.
Or you can have, let's say, a straight bridge on a curved alignment as well. And
You play with the bearing offsets, right? The distance between beams, that's how you play it with it and the beam layout.
yeah. Well, or let's say you have a curved alignment and you just use point controls for the left and right edge of pavement. You can force the left and right edge of deck to be straight, and then when you lay out your beams, you just, and let's scroll out here and find my beam layout here. Oh, I've got it turned off. In the, let's just go this way, beam layout. In the beam layout, you can tell these beams whether they're corded or not.
Yep.
And that can also force them to be straight as well. So, and that's actually the default. If you're doing precast girders, it knows, hey, those are going to be straight. So when you go to lay these out by default, they're going to use the cord anyway, even if, regardless of what the whether the edge of deck is straight or not. So you can force it to use the cord here and be fine. Not today. So next question there, is there a Camber Report Leap Steel that can be output from that program? Yes, Leap Steel can do some very detailed Camber reporting, and they are looking at bringing that information back into OBM, but that's not there today. So today you'll use Leap Steel to generate any and all Camber reports you want. Okay. Is it possible to generate a report for deck bottom elevations, including thickened edge? Not today, not that I know of. I don't know if Alex, if you know of a way of doing that. I think it's just for deck top.
No, it's deck top. Could it be the other reports? No, the beam, no.
No, beam. I mean, we give you the top and bottom of beam.
Camber give you the screed.
Yep.
It give you thickness though on the camber. Pull up the camber report. It give you some information that you can extract it from there.
Yeah, but not really deck bottom. I mean,
deck bottom, no. It give you the distance though.
Yeah, but I'm picturing, using like the solids modeling tools, you can extract a line along those, but there isn't really a simple way to report on
deck bottom,
a line that you've generated yourself. You could certainly draw that 3D linear element, but I'm not aware of a way to do that. But we do give you, like I said, the haunch elevations.
Yep. Yeah, the haunch elevation thing is along the way.
Yeah.
Yeah, but not at the, nah.
Yeah, not today. But there's always more reports that could be added in the future as well here. So, but that's probably the first time I've asked for that. So I've heard that asked. So, all right. With that, I think we'll go ahead and stop here. I want to thank everybody for attending. We did record the session, and it will be posted here probably in the next couple of days or so. Otherwise, we'll see everybody in about 2 weeks, and just want to wish you all a great holiday. And thanks for coming.